Welcome to today's webinar. I'm Trident University Marketing Specialist Daniel Sloan, and we're excited to be bringing you today's Culture of Research and Education webinar. The core webinar series is designed to provide faculty, students, and alumni an opportunity to share their research and scholarship with the Trident community. By fostering a culture of professional development and idea exchange, participants will have access to a valuable forum for lifelong learning. This university-wide effort is coordinated by Trident's doctoral studies directors. A few notes before we begin today's session. You're welcome to ask questions, share comments and experiences at any time. We'll have a Q&A session at the end of the webinar where Dr. Lee and today's presenter, Dr. Carey Ford, will be available to answer your questions. You can find your question box about halfway down on the control panel on the right-hand side of your screen. And likewise, you can email me directly, daniel.sloan@trident.edu, and can collect your questions there. This webinar will be recorded, and all attendees will receive a link to this webinar and a copy of the slides by early next week. Today's session will be hosted by Dr. Wenlin Lee, Doctoral Studies Director in Trident's College of Education. Dr. Lee holds her Ph.D. in cognitive psychology from Beijing Normal University and has postdoctorate experience in the Department of Psychology at the University of Illinois at Urbana-Champaign. Dr. Lee was Senior Research Scientist at the Center for Study of Reading at UIUC prior to Trident. Her primary research interests are reading, writing, and instructional approach in K-12, and school leadership and administration. She has authored 7 books and numerous articles on dynamic issues in children's learning and language mastery. Welcome, Dr. Lee. The floor is yours.
Thank you, Daniel, for your great introduction. Good afternoon, everyone. I'm so pleased to have such an opportunity to meet you all here. I'm very glad to introduce today's presenter, Dr. Carey Ford. Dr. Carey Ford currently serves as mentor in the College of Education at Trident. This role also includes teaching the course statistics, definitely it's advanced statistics in PhD program. He holds a PhD in sociology from Wayne State University in Michigan. His areas of focus are research methods, statistics, race relations, criminology, and social justice. He has worked as a research associate, department chair in social science, and a professor at various institutions in Michigan. He has also worked as a dissertation consultant with the doctoral learners. He has also served as vice president of K-12 school board for 5 years. His research interests include stress and online doctoral learners, social justice movements, and police community relations. Welcome, Dr. Ford. Now give the floor to Dr. Ford.
Thank you, Dr. Lee, for that introduction. And today's webinar is focused essentially on an overview of statistics and the steps in which one should take to generate stats, and wanted to give folks some options and to let people know that there are kind of tricks of the trade that one can use to utilize various statistical tests based on the variables and the data that they have at hand. And so I kind of wanted to go through some of those, as well as some of the options in SPSS, knowing how to transform data, some of the mistakes that one may make, and then just give a general overview of some of the resources that kind of capture what we're talking about today. So when we think about statistics, we think about various terms, terminology. We also kind of think about, you know, what we're going to do based on the data that we're using, And in our next slide here, we have various levels of analysis. And the expectation for doctoral students is that you cover all three levels: univariate, bivariate, as well as multivariate analysis. Okay. And so I know in some instances, someone may think that they can run a bivariate analysis and then that is all that is required. And so when we're talking about scholarly research, we're oftentimes talking about running some form of multivariate analysis where you're controlling for additional variables. And so I've broken these down into various families, those being descriptives, which is what it says. You're just describing data. And if you have continuous data or data that increases or decreases, whether it be weight, height, income, age, it's appropriate to generate a mean or average or a median or standard deviation. If you are working with categorical variables and you want to run descriptive statistics, then you're going to focus more so on frequencies. So it's not appropriate to try to generate a mean for race or gender. Okay, so we want to make sure that we understand what specific type of descriptive analysis we're going to use based on the data at hand. The next level of analysis is called bivariate because you're looking at two variables in relation to one another. And if you go over to the relationship family, you have various options. This isn't meant to be all inclusive, but you have the correlation test, which most people refer to as Pearson's, but then you have other correlational tests as well. You have something called Spearman's row, or some people like to call it Spearman's rank, because there you're dealing with ordinal data. You also have a test called the chi-square test, which may be more appropriate depending on what type of data you have, whether it be ordinal or categorical. But notice as we move down to that next level in that same family called relationships, you have multiple regression and logistic regression. And I'll just kind of pause a minute here to make this point. Usually, when you start out with a certain family of statistics, you carry that out all the way through. So normally you don't see someone jump from running a correlation analysis or chi-square, and then they go over and they run a MANOVA or Mancova, because now you're kind of mixing things and you need to have alignment when it comes to your hypotheses and your wording. So if you're looking at relationships between two variables, you want to stay within that family of relationships. And even though multiple regression and logistic regression focuses more so on predicting variables, it's still looking at a relationship. That's different from our last column, which is the family that deals with differences in means. And for the bivariate analysis, we have a t-test. So you may want to look at the differences in test scores between males and females. And then we also have the ANOVA, which is really just a step up from the t-test. Now we're dealing with an independent variable with maybe 3 or more categories. So you move away from gender, and let's say you're looking at race with Asian Americans, African Americans, and Latino Americans. Okay, and you still want to look at differences in mean test scores. And so when you move to the multivariate level, you stay with that differences in mean scores, and now maybe you run an ANCOVA where you add a covariate, and maybe you control for something like age, or maybe you control for educational level. The MANOVA is in the same family. Now you're looking at 2 or more dependent variables and differences in means. And then we have the Mancova where you add a covariate to that. So it's important that you know the relationships and differences in means family test so that you can stay consistent and make sure that your wording and your research questions and your hypotheses matches what you're doing on these levels. So if you start out talking about relationships and your hypotheses, and then you run an ANCOVA for your multivariate analysis, well, you should have a hypothesis that deals with differences in means. And so it's important that you stay consistent. Okay. And so that is also why, as we move past the levels of analysis, that you understand terminology. Sometimes we get confused, and you have a lot of synonymous terms in stats, and they pretty much mean the same. So don't allow that to confuse you. We have our, dependent variable, independent variable. I think those are self-explanatory. Dependent variable is the variable that's being impacted, and the independent variable is the one that is doing the impacting. Well, if we move down to that second row there, the criterion variable is analogous to the dependent variable. People sometimes use the word criterion in running the analysis with relationships because you don't have control over the independent variable and placing it in certain categories or certain conditions. Okay, so that's why sometimes you'll see that. But the criterion is the dependent variable. Just know that. The predictor variable is the independent variable. We're talking, about the same. And then down below that, you have the words control and covariate. These terms are synonymous. We're talking about the same. So we're just taking into account additional variables. And when you're running multivariate analysis, it's important to have control variables, especially those that kind of tie into the literature and the theory that you may be using to guide your research. Okay. All right. So as we move on to assumptions, which you must know these. It's important to know your variables, how they're measured. Is your dependent variable continuous? Is it categorical? Is it ordinal? And same for your independent variables. How are they measured? And what do you need to do? Well, actually, how do they match up to the assumptions of the statistical test that you would like to use? Okay, so that's really one of the first main assumptions, is to kind of look at your variables and do they meet the requirements for any statistical test that you seek to use. Another common assumption in the field of statistics is called normality. And what does that really mean? Well, statistics operates on this theoretical premise that variables, for the most part, have most of their values or cases cluster around the mean. Actually, 68% within plus and minus 1 standard deviation should cluster around the mean. Well, notice how I said theoretically, because in my 20 some odd years in dealing with stats, it is rare, very rare, to find a variable that is perfectly normal. You're always going to have some measure of skewness, and meaning you have a disproportionate number of cases to the right or left of the mean. Okay, so that does exist. What we really worry about in stats is extreme skewness, to the point where it will throw off our results. And more importantly here, for this slide, it violates the assumption of normality in order to use a specific statistical test. Okay, so, but never fear, you have options. And in looking at those options, you don't necessarily have to totally junk the statistical test that you're seeking to use. So let's say you want to use multiple regression and you want to use it to predict blood pressure, and you have some element of skewness. Well, you don't have to like totally say, well, can't use multiple regression, let me go on to another statistical test. There are transformations that can be utilized first before you totally move away from that test that you're seeking to use. And some of those I've listed here. Recoding is a common data transformation that's used. Multiple regression requires continuous data or continuous variables. However, you can use categorical independent variables if you recode them into what are called dummy variables, where you'll have two categories, one category coded as a 1 and the other category coded as a 0, and you're just comparing those categories. Okay. You can also correct for skewness. And a lot of times people will use a histogram to assess skewness. It's just a basic visual chart. But then there are other ways. Some people will divide the actual skewness statistic, by its standard error, and to assess skewness. There's also something, another statistic that you can use as well. That escapes me right now, but there are various ways that you can assess skewness. But for the purposes of this particular webinar, we just want to focus on the histogram. Oh, and that statistic is called the Wilks-Shapiro test. And essentially, if you run the test and you find statistical significance, then it means that your variable is significantly different from a normalized distribution, meaning it's skewed. Okay, so that's the test that I was referring to. But your next question should be, well, where do I go in SPSS to perform some of these transformations? Well, as we move into SPSS and into looking at various options, if we move on to recoding and dummy coding, if you look at transform at the very top of that screenshot, that is where you'll find a lot of the options that you need in order to transform data. That's where you're going to go to recode, and you have two options in terms of recoding. You can recode into a new variable, which I recommend, or you can recode into your existing variable. I say new variable because what if you make some mistakes? What if you want to go back maybe a week, 2 weeks, month from now and analyze the original data, as it were? Well, now you've already recoded it into a different variable, and you've lost that. You've lost those original values. So I highly recommend recoding into a different variable, a new variable. So if you mess something up, oh well, you still have your original variable and its values. Okay. And don't want to go through all of the steps, but quite frankly, you just select the variable on the left that you'd like to recode, and then you move that over, and you can give it a new name, which will be the name of the new variable, and then you can go in and recode those values. So let's say you have a variable called patient groups, as we do here, and you have a total of 3 groups, and those patient groups are those patients that have been diagnosed with cancer, those that have heart disease, and then those that have arthritis. Well, let's say the literature says, well, heart disease is an indicator of arthritis, or it leads to arthritis. Well, you may want to condense arthritis and heart disease into one category and then compare that to the cancer group. So that's just a practical example why you might want to recode or collapse variable categories rather. Okay. All right. So you have that option there, and there are several videos out that will walk you through dummy coding, especially those on YouTube. So it's a fairly simple process. All right. As we move on to data transformations, remember normality. And essentially, we're talking about skewness. Look at the variable to the left. We've run a histogram. That variable is named blood pressure before treatment. Notice how it's symmetrical in its shape and its distribution. It's kind of even on both sides. But then look at the variable called weight on the right-hand side. Notice how the distribution is a little one-sided. And if you look at the tail of the curve, which is flattest to the right, that's the side that it is skewed to. So I'll say that again. When you're visually assessing skewness, the tail, the side where the tail is the flattest, is the side where the skewness is shown or indicated. Okay, it's not terribly skewed, but we can see it is different from our histogram on the left. Well, what can you do about that? Can you not use this variable now in multiple regression? Well, again, as I said, you have options. If you go back to SPSS and you go to transform and you go to compute variable, here you can create a new variable that corrects for skewness. And we saw that our variable was skewed to the right. There is something called the natural log, and you can transform that variable into natural log units. And I've shown you with the red arrow down at the bottom there with that where that function is. It's called ln. And then you just quite simply put that in the numeric expression box. And then you put the variable that you'd like to take the natural log of. Okay, and it does that for you. And it will show you a new variable in your data editor window representing the natural log of the original variable. Now, I will say this. If you are correcting for skewness to the right, normally we take the natural log of that variable. If you're correcting for skewness to the left, we normally square that variable by itself. And notice how this is a little calculator pad. So your target variable would just be a new variable name. Let's call it squared. And then you would just quite simply multiply weight by itself. Weight times weight. And we use the little asterisk on the calculator pad to represent multiplication. Okay, so it's very simple. And why do we do it that way when we have skewness to the left? Well, remember, skewness to the left of the mean, it represents negative values. Well, if you go back to high school, early college years, you know your integers and dealing with various numbers, a negative times a negative is a positive. So we're correcting for negative skewness by kind of straightening it out to the positive side, if I could say it that way. Okay. All right. So, and I want to show you the difference. So remember our original histogram, weight, which was skewed to the right. And then we took the natural log of that variable. And now look at it. Notice how it's kind of straightened out, how it's kind of a little more symmetrical than its original form. And if you were going to interpret this in regression, you would just speak in the form of percentages. Okay, so for every unit, let's say for every unit change in age, there would be a percentage change in weight. Okay, so these are tried and true methods. They've been around for a while, and so you know, you don't need to reinvent the wheel. There are things that you can do. You just need to be aware of them. Okay, so as we move on past our histograms, what does this really mean in practice in terms of implications? Well, you definitely want to be able to assess options for statistical tests. Can the data be transformed? Now, sometimes you may have a variable that is so skewed that even when you square it, if it's skewed to the left, or take the natural log when it's skewed to the right, it still doesn't really correct it. Well, in those instances, then you want to move into other statistical tests. And I've given you an example here. Let's say you'd like to analyze the relationship between gender and life satisfaction. And life satisfaction is an ordinal variable measured as not satisfied, satisfied, very satisfied. And we want to assess the relationship. Well, a lot of people will automatically think about Pearson's correlation because it is the most common correlational test. in terms of looking at relationships. But one of the assumptions of Pearson is that you have continuous data in addition to normality and all the other things. But what if you don't have continuous data? Okay, well, maybe you move to our second option, which is Spearman's row, or some people like to call it again Spearman's rank, which is appropriate for ordinal data. So it still allows you to assess the relationship just like Pearson's, but it's appropriate for ordinal data. But I just mentioned that you have gender and life satisfaction. Only one of your variables is ordinal. The other is categorical. And so now we move down to our third option. Still looks at relationships, the chi-square test. And here it's appropriate to use 2 ordinal variables, 2 categorical variables, or 1 ordinal and 1 categorical variable together, which is what we have here in this case. So that's what I mean by knowing your options and knowing the statistical tests that are available, and using those appropriately. So you can still look at relationships. It's just using a different test. You don't have to totally junk your relationship premise. Okay, so that's just an example. And then we have other, and these are called the 2 tests under the Pearsons are called non-parametric tests, and those are the options that people usually turn to when their data doesn't conform to parametric tests, such as the Pearson's correlation. And when we say parametric, it means that there is a number or parameter in the population that we can associate with our statistical analysis, our statistical numbers. Okay. All right. Okay. So that is a good practical application of why you would need to know your options and how to go through that sequentially, step by step. Okay. All right. So as we move to the next steps, if you've gotten a chance, if you haven't, but if you've gotten a chance, you've seen a list of past Trident webinars. Okay. Those webinars go together. And what I mean by that is they build off of one another. We have a webinar that is associated with quantitative methodology. We have a webinar that deals with the power analysis, which helps you determine the sample size that you need in order to run these statistical tests that I just referred to. So you want to begin to review the Trident webinars and begin to put them together like pieces of a puzzle and see how they work with one another and build off of one another, because they do. And you should see some overlap as well. Okay, so that's a good starting point. The second is, let's say you're taking a stats class and you're a graduate student. Well, you definitely want to build a portfolio and begin to save your resources. In the modules on the background page, they have various resources. They have articles, they have video links. You should save all the above. You may be able to use some of those articles as justification in your proposal or dissertation for using a specific statistical test. Okay. So you definitely want to keep a running log of the resources that are being used in your courses. And then lastly, which I have highlighted here in red, is to begin to compile specifically resources that can help you get through analysis. And there is a site called Layered, LAERD.com, which is increasingly popular with graduate students because it is really a one-stop shop. If you go to the site, they can provide you, 1, with the assumptions of any statistical test. 2, they give you the SPSS screenshots as to how to run the analysis. And 3, they provide output and interpretation examples. So that is one site that I would highly recommend for anyone who is trying to kind of learn and walk through the steps of using stats. There is a subscription fee, and I think it's kind of segmented out based on how many months you'd like to subscribe, and that will determine the price. But however, if you simply Google layered and a statistical test, it will give you that free. It will pop up as a link. So you can just simply Google. So layered and multiple regression, layered and normality, layered and t-test. Whatever you'd like to know statistically, just put in the term layered and put in your stats question, and it should give you a page for free. Okay, so you won't have access to the full site, but you'll have enough to go on and to get started. YouTube is obviously popular. You have several videos on there related to various statistical tests. I would just caution people to make sure, one, that it is the test that you are specifically looking to use, and two, that it's reputable. And I think they have a person, Dr. Grande. I think he's pretty popular on YouTube, and he's done quite a few videos. So, so just make sure you're looking at what you intend to look at, and that video is reputable in what it's stating. And then APA format is also very key. They have a website called OWL, OWL, and they give you examples of how to kind of set up various things in terms of APA format. It's imperative that students are putting together statistical tables in APA format. It's not acceptable to just cut and paste from SPSS output into your paper or your draft. Okay. And then also in relaying those results, there's a scholarly way to do so as well. And this kind of goes back to the previous point. You should be learning that in classes if you're a doctoral student, and you want to take note of that. So it's key that you do that. And so as we kind of move past the next steps, just to kind of summarize what we've covered today: know your data, know your variables, how they're measured, understand the statistical test assumptions of any test that you seek to use, and you want to kind of compare and contrast that with your variables. That's why you need to know both. Explore your options. We have non-parametric tests that we can use, and I gave you an example of that. Know SPSS. Know how to maneuver through there and understand how to transform data that you'd like to transform. And then lastly, I'll say this again, is that a lot of the issues and pitfalls and roadblocks that you're going to encounter, they are not new. They've been around for several years, and you know, the field of stats has has options for you to get around those. You just need to know where to go to get those, and to understand what you need. So don't be afraid to use the resources around you, because the answers are out there. This is not something that you have to sit and just kind of, come up with yourself. So, and I mentioned just a few of those. Those of you who are looking for scholarly resources, Sage Publications is a good source. And then if you just go in and search Sage and normality, it'll give you what I basically talked about, and then you'll have a citation for that if you needed a citation to put in your paper. So we have several things out there. I would just say be sure that you are familiar with the steps, know your options. That helps to kind of build confidence, and then you should be able to take off from there. And I know a lot of folks like to get into the results and what should I do with the hypotheses? Should I accept or reject the null? How does that relate to? All those things are important. But if you don't follow the necessary and proper steps leading up to that, then your data loses credibility and your findings don't have the weight that they should carry. So these are the steps that you really should focus on so that when you get to your results, you have something that's credible, that's rigorous and kind of upholds the rigor of what is expected in terms of doing research and statistical analysis. Okay, so with that, I will hand it back over to Dr. Lee. Thank you.
Great. Thank you, Dr. Ford, for the great presentation. The steps of statistics are so critical to all doctoral students. I know many students are anxious about statistics. I hope this presentation helps a lot to our students' dissertation study. Now let's give back the floor to Daniel for Q&A session.
Great. Thank you, Dr. Lee. Thank you, Dr. Ford, for the presentation. And there's one comment Dr. Ford made during the presentation, which I wholeheartedly agree with. When I graduated from my MBA program, I was going through all my notes. I'm like, what should I keep? What shouldn't I keep? And I was like, these statistics notes might come in handy one day. And at the time, never thought that they would. And after some back and forth with my wife, who kept calling me a pack rat, I was, now that I'm in a doctoral program, again, they are useful. So, and she likes saying that I just decided to go in the program so I could prove her wrong, but it's really useful to hold on to that stuff. And we do have a couple questions, and as a reminder, if you do have a question, please submit it in the control panel, the question box that halfway down. You can feel free to ask questions to either Dr. Ford or Dr. Lee. The first question I have for you, Dr. Ford, is when you're, as a student who's coming into statistics who's very uncomfortable with it, are there specific resources you recommend where people can go just to practice and get more comfortable with the process?
Great question, and I'm glad that that person is thinking along those lines, because that's exactly what it boils down to, is practice. And the more you practice, the more you build your confidence. So I think one of the sites that I would recommend would be Layered. It's not an interactive site where you can practice, but it gives you the foundation and lets you kind of know what you're doing and why you're doing it. In terms of practice, I would just use YouTube as a practice guide and try to replicate some of the findings and results that are being replicated in some of the videos. I would start there. Part of getting comfortable too is learning SPSS. Well, where do you go to analyze descriptively? How do you run a frequencies analysis? How do you run a correlation analysis? Well, use YouTube as a guide and just see if you can't replicate those steps. After watching the videos and you turn the video off, see if you can't do it on your own. And what I'd like to kind of convey to students is, once you're able to get the steps in SPSS, once you're able to generate the analysis, okay, well, now what does the analysis mean? That's your next step. What do those findings really mean? How can you explain that to a layperson? So that's what I would say.
Great, thank you. Next question, this one is for you as well, Dr. Ford. Student has the SPSS grad pack. Will this software satisfy his needs for stats 1 and 2?
From what I remember, yes, but what I would say to the student is make sure that that grad pack that you have has options for multiple regression, logistic regression, factor analysis, and MANOVA. If you have those, then you should be prepared for statistics 2. Now, we have had some instances where maybe folks have gotten a certain version and it prepared them, it was appropriate for statistics 1, but it didn't have all the options that were needed for statistics 2. And maybe Dr. Lee can kind of chime in on this as well.
Yeah, Dr. Ford, you said right. Grad Pack should have multiple regression MANOVA as well. If you have like a basic version, it doesn't have, but it's a grad pack, it should be fine.
Thank you, Dr. Ford. Thank you, Dr. Lee. Next question for you. They're starting to come in quickly now. Dr. Ford, when considering left skewness, can all types of data be squared and ordinal as well as continuous?
No. Usually when we run a histogram, we're running a histogram on continuous data. So that's a starting point. So usually you're already dealing with a continuous variable. Okay. So not ordinal, not nominal. Usually you have a continuous variable that you're already starting with. And that's one that would be appropriate for squaring or taking the natural log of.
Okay, great. Thank you. And next question, this is more of a general one, but Dr. Ford, how would one go about determining what a statistically significant sample size is for a study?
Okay, so that goes back to kind of what I said earlier about looking at the webinars as pieces of a larger puzzle. I would urge that student or that person to go back and look at the webinar related to the power analysis, because what's going to determine your sample size is what statistical tests you seek to use, whether it be MANOVA, Mancova, multiple regression, and the number of variables that you have, but also your level of power. So there are different factors that go into that can influence the minimum sample size. So I would urge that person to review that webinar, and that can give them some more specific information about how to do that. I would also add that once you determine your minimum sample size, try to shoot for more than your minimum. And I say that because let's say your power analysis reveals a minimum sample size of 200 people, and you shoot for 200 people. You send out a survey to exactly 200 people. What if 2 people don't respond? Well, now you only have a sample size of 188. So it's better to go over and above. So if you have a minimum sample size of 200, send out 280, send out 260. So if all the people don't respond, you still have more than enough to complete your requisite sample size. And I will say this, if you don't have the sample size that's specified, then that also impacts the credibility of your findings. And it's very difficult to go back and recollect data. So you want to do that appropriately the first time. Thank you.
Great. Thank you. Yeah, and those webinars that Dr. Ford is referring to, those are all actually available on Trident's website, and we can send those links around. The power statistics one was actually presented by Dr. Mickey Shakar, who is the dean of College of Health and Human Services, and there are 2 very valuable webinars on qualitative and quantitative analysis, both presented by Dr. Carlos Cardillo.
Mm-hmm.
And next question, this one is for you, Dr. Lee. For those of us who are very advanced in a doctoral program, is there any way we can access background information from past classes?
Daniel, so what background information? Could you clarify?
I'm not sure. This is a general question. So the person who asked that, could you clarify, and then we'll circle back to you. Thank you. Next question for you, Dr. Ford. Is dummy coding only appropriate for continuous variables?
No, it's not. It's also appropriate for categorical variables. And so let's say you'd like to use multiple regression. Well, the main assumption for multiple regression is that you have linearity, or you're using continuous variables. One way to get around that is you can dummy code a categorical variable, and then you can use it in regression. So let's say you have, I don't know, let's say you have race, and you have Latinos, you have Asians, you have African American, but you only want to focus on Latinos and Asians. Well, you can combine African Americans with Latinos, and then, compare those to Asians, and now you have your dummy variable. So you cannot use categorical variables with multiple regression unless they are dummy coded. That's a better way of saying it. So you must dummy code categorical variables, and it is doable. Yeah.
Okay, thank you. And Dr. Lee, to follow up from that previous question, this student is referring to readings from background sections, or the go-to section for information within each module.
So the question is whether they need the background information for their module.
Yeah, background information from past classes, and the readings from each module.
Yeah, definitely. The course design, we set up like background reading, and all the readings are related to, the objective of each module, and also related to your assignments. So, my suggestion is you have to understand, like the concepts you have to learn, and you read the background, you learn about, the previous research. That is a good resources for your assignments.
Okay, thank you. And that is actually our last question. So I do want to thank everyone for submitting questions, and Dr. Ford for the presentation, and Dr. Lee for hosting. I don't know if you have any last words before we close things out tonight. Okay, thank you. And if you do have any additional questions, please send them in, and then we'll have Dr. Ford or Dr. Lee get to them afterwards. So if you want to learn more about the core webinars, including some of the archived ones we were talking about, the link to get to them on the screen. And we do have a new LinkedIn group available now for doctoral students and alumni, where you can share information, network. And our next core webinar is going to be in April. Details are right around the corner. And there's more information about core and our doctoral programs, and contact information is up on the screen now for both Dr. Ford and Dr. Lee. And of course, we'll be sending out the slide deck early next week. And thank you again, everyone, for attending. Thank you again, Dr. Ford, for this really important presentation, and Dr. Lee. Have a great night, everyone.